Hello everyone, today we are going to talk about the periodic table, that how we arrange all the elements in a periodic table. So let's start. You can see on your screen the periodic table. So the first thing in the periodic table are the groups. You can see here they arrange the groups or they arrange the elements in the group from top to bottom. So there are total 8 groups. Group 1, 2, 3, 4, 5, 6, 7 and 8. So 8 groups are there. And when we talk about the periods are when we are going to move from the left to the right side, and there are 7 rows, or you can say there are 7 periods. Now we arrange or we divide the elements into two things, the metals and the non-metals, and 3/4 part of the periodic table is consist of metals, where the other part consists of non-metals. Even you can see here we divide them. These all things are the metals and these one are the non-metals. So this is about the metals and the non-metals. Now next thing, the chemical elements are arranged in order of increasing atomic number. Even you can see hydrogen, the first one has a atomic number 1, helium has atomic number 2, lithium 3, beryllium 4. So we arrange all the elements according to their increasing atomic number, not atomic mass. Next thing, all the elements that are present in the same group, they have same number of electron in their outermost shell. For example, when we talk about the group 1 element, hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium, they all have 1 electron in their outermost shell. So when we talk about group 2 elements, they all have 2 electron in their outermost shell. Group 3 has 3. When we talk about group 7, it means they have 7 electron in their outermost shell. When we talk about the periods, this is all about the group. Group number tell us the number of electron in the outermost shell, where the period number is tell us about the number of shell. For example, all the elements in the first period, they have 1 shell, like hydrogen and helium, they have 1 shell totally. Second period, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluoride, and neon, they have 2 shells in complete one. Now I told you that we divide all the things into metals, all the elements to metal and the non-metals. And metals contain most part of the periodic table. So we should know what the metal are. The biggest example of metal is the gold, and you can say they are the good conductor of electricity and heat. They are a giant structure in which electron is the highest energy level and free to move through the entire structure. With the non-metals, they are the bad conductor of heat and electricity. Why? Because they don't have the free electron. Metals have the free electron who can move easily and can conduct heat and electricity. With the non-metal, don't have the free electrons. Again, move toward the group number. I told you the group number tell us what? The number of electron in the outermost shell. Here is the example of oxygen. Oxygen belong to which group? You can see oxygen in group 6. So what does it mean? It means it has 6 electron in the outermost shell. The first electron, I told you about the electronic configuration. The first shell contains 2 electrons, second contain 8, then 8. So for the oxygen, there are total 6 electrons. Sorry, there are 8 electron. Means 6 belong to group 6. It means they have 6 electron in the outermost shell. And if I am going to draw the structure, here is the first. And oxygen also belong to which period? It belongs to second period. It means 2 shells should be there. The first shell contains 2 electron. The remaining 6 are there. Hope so it is clear to you that how many electrons are there in oxygen? Total 8, 2 in the first shell and 6 in the second. As I told you before, the period number tell us how many shells are there. Here they give the example of the calcium. Even you can see the calcium here in the periodic table is belong to period number 4. This means it has 4 shells in total. You can see the diagram. How many shells are there? 1, 2, 3, 4. How many electrons? It belongs to group second. So there are 2 electrons in the outermost shell. Even you can see here that it contains only 2 electrons. Now we have to talk about the groups and their chemical properties. Why we arrange the elements, how they are going to react, it all depend upon how many electrons they have in the outermost shell. If the outermost shell is completely filled, mean they have the 8 electrons in the outermost shell, they are not going to react. But if they have 1 electron, 2 electrons, 3 electrons in the outermost shell, they are going to react more easily. And the more reactive thing means they have 1. If there is a 1 electron in the outermost shell, they will react with more speed. Atoms need to lose or gain electron in order to become stable, like group 8 element that are the noble gases. So metals have the ability to lose electron and they are going to react with the non-metal, and non-metal have the ability to gain the electrons. Few elements that need to lose, lost or gain, the more reactive the element. Here is the example of the metals. The first group metals, they have 1 electron in the outermost shell, so they are the more reactive. It is easy for them to lose 1 electron, so that's why they are more reactive. In the same way, when we talk about group 7 element like chlorine, bromine, iodine, they have to take 1 electron, so it's easy for them to gain 1 electron, so they are not most reactive non-metal. For the metal, the group 1 element, and for the non-metal, group 7 elements are the more reactive one. The fewer elements that need to be lost or gained, the more reactive the element. Group 1, as I told you before, are more reactive, and group 7. But the group 8, why they are unreactive? You can see here in the diagram, the electronic configuration. The first shell contains 2 electrons. So the first one, helium, that has 2 electrons in the outermost shell, that is completely filled. Neon, it has 8 electrons in their outermost shell. In the same way, argon has 8 electrons. So the outer shell is completely filled. So that's why they don't need to react with anything else. They don't usually react, and we also call them as rare or noble gases. That is all about today's lecture. If you got any question, you can ask. Take care. Bye.